and the 2002 parametric FRQ equation. So initially, similar information is given to us that has been given to us in the other problems. We've got dx dt and dy dt, and it also tells us this position 1, 5 at time t equals 2. So we'll definitely be asked to find a coordinate at a different point with given that information. So part A, it says, is the horizontal movement of the particle to the left or the right at time t equals 2? Horizontal movement is all about dx dt. So we need to figure out what dx dt is at t equals 2. If this is positive, it means to the right. If it's negative, it means to the left. So what I've done is I've set up the x prime of t and y prime of t in the calculator. I just want you to take note at putting in y prime of t. Watch your parentheses. You're squaring all of sine of x. So make sure that is done correctly. But all I need to do here is find the value of x prime of t at 2. So I'm going to plug 2 into that function, and we get back 0.271. Now clearly that is greater than 0. So what that indicates is that at t equals 2, the particle is moving right. Then we have another part to this question. The other part of the question is saying, find the slope of the path of the particle at time t equals 2. Whenever we're talking about slope, we're talking about the slope of the tangent line. So that means we need to find dy dx at t equals 2. And that's going to be equal to y prime of 2 over x prime of 2. And we'll have our calculator do that. So y prime is in y2. So I'm going to do alpha trace y2 of 2 divided by y1 of 2. And that answer comes out to be 3.054 or 3.055. All in, this part A is worth 3 points. This analysis of moving to the right is going to be a point, and you're going to get a point for basically writing this out here, and a point for your actual numeric answer. Question B says, find the x-coordinate of the particle's position at time t equals 4. So we want the x-coordinate at t equals 4. So if I want the x-coordinate, I'm going to do the integral of dx dt. And I want the value at t equals 4. They give us information about t equals 2. And they tell us the x-coordinate is 1, so that 1's going to be important. But the 2 and the 4, those t values are going to be the endpoints of integration. And then that will equal x of 4 minus x of 2. So we need to get this value from the calculator. So we'll do math 9 from 2 to 4 of y1, that's where x prime is. And that gives us 0.253, and that is going to equal x of 4 minus x of 2, which we know to be 1. So x of 4 is going to equal 1.253. And that is our x-coordinate. This question is a 2-point question. You get a point for setting up the integral, and you will get a point for the final numeric answer. Question C. Find the speed of the particle at time t equals 4. Find the acceleration vector at t equals 4. Super easy questions. We're looking for the square root of x prime of 4 squared plus y prime of 4 squared. We've done this now for both questions on the calculator, so I'm just going to give the answer. This comes out to be 0.575 or 0.574. And again, that's going to be 1 point for the speed. The acceleration vector is going to be the second derivative at 4. Again, I want to make sure you're using your calculator properly. Don't be doing the derivatives on your own. So for this case, we need to do the derivatives individually. So I'll do math 8. Derivative with respect to x of y1 at the value of 4. This gives me the second derivative then, because I'm doing the derivative of the first derivative. So we got negative 0.041. And then the y-coordinate, I'll do the exact same thing, but with my y2 equation, which represented y prime. That is 0.989. And that is a point for that. Question D. Find the distance traveled from the time 2 to 4. Again, we've done this now for both problems. So it's a matter of setting up the integral from 2 to 4 of x prime of t squared plus y prime of t squared. So those are in your calculator in y1 and y2. Have the calculator do the work. The correct answer is 0.651, or you could also have 0.650. How many points is it? 2 points. 1 point for the integral, 1 point for the answer. And we are done. That was an easy one.